The BMW S1000RR, a true engineering marvel, is crafted with precision and expertise. Witness the journey of its creation from initial design to its rigorous final tests. Every S1000RR design starts with the most fundamental tools, a pencil and paper. This traditional approach may seem simple, but it is the foundation of the bike's innovative and striking design. Before any computer modeling or engineering begins, designers use sketches to explore their creativity, which may build on what's already trending. With a pencil in hand, they bring their ideas to life, imagining how the bike will look, feel, and perform. It's also in this stage that the designers incorporate any feedback from users riding any previous models. The sketching stage allows them to experiment freely, refining the basic shape and contours of the bike without the constraints of software. This process also gives designers the flexibility to focus on details like aerodynamics, balance, and proportions, ensuring the bike looks dynamic while maintaining its performance capabilities. For example, the sleek curves of the S1000RR are carefully considered at this stage to reduce wind resistance while enhancing its aggressive stance. From pencil and paper, the design moves to advanced computer-aided design tools for refinement. You will also find the use of CAD in many other applications, such as designing ships and airplanes to make them safer and more efficient. It is also used in industrial and architectural design to plan factories, buildings, and homes with precision. In construction, CAD is a big part of building information modeling, which helps teams create detailed 3D models of projects before they are built. CAD is used in healthcare to create prosthetics, like artificial legs or arms, that fit perfectly. These are just a few examples, as CAD is useful in many other fields as well. After the initial design is sketched with pencil and paper, the next step involves bringing these ideas to life using CAD software on a computer or workstation. This technology plays a crucial role in refining and optimizing the hand-drawn concepts into precise, detailed digital models. CAD allows designers to take the rough outlines of the sketch and transform them into accurate 3D representations of the bike. This process ensures that every curve, angle, and proportion aligns perfectly with the intended vision while meeting performance and safety standards. For instance, CAD enables designers to test and adjust the bike's aerodynamics, ensuring it cuts through the air efficiently at high speeds. One major advantage of CAD is its ability to simulate real-world conditions. Designers can analyze how the bike will handle stress, heat, and wind, identifying potential weaknesses before a physical prototype is built. It also allows for intricate detailing, such as ensuring components like the frame, fairing, and engine housing fit together seamlessly. Moreover, CAD provides flexibility for experimentation. Designers can easily make changes, try different materials, or modify shapes without starting from scratch. This tool bridges the gap between creativity and engineering, ensuring that the final product is not only visually stunning, but also functional and performance-driven. So, once the initial sketches are ready, soft clay models are created to give the design a physical form to help visualize the bike's proportions and make adjustments. It's a hands-on way to bring their ideas to life. But is designing on paper and creating computer models enough to move forward with production? Not quite. Even with advanced computer technology today, digital models alone are not enough to fully evaluate a design. You need something you can see and touch. This is why automobile manufacturers take additional steps by creating scaled-down models, often at a ratio of 1:4, and eventually life-size models at a 1:1 scale. These physical models give designers and engineers a better understanding of how the final product will look, feel, and function in the real world. For this stage, designers require a material that is soft and easy to shape, but durable enough to hold its form. And this is where clay modeling comes into play. Clay plays a pivotal role in the vehicle design process, offering a tangible, hands-on medium that bridges the gap between digital models and real-world prototypes. While CAD and computer simulations are vital for precision, Clay modeling allows designers to physically sculpt, refine, and perfect the prototype, ensuring the final product is both functional and visually striking. Designers can use clay to make shapes on the bike's surface and test how well it moves, looks, and feels. For example, the smooth curves of a motorbike's body, which are essential for reducing wind resistance and enhancing speed, can be carefully fine-tuned by hand. Similarly, intricate details such as the contour of the headlights or the ergonomic placement of mirrors are adjusted using clay to ensure they blend seamlessly with the overall design while meeting functional requirements. Clay modeling also offers flexibility that digital tools cannot fully replicate. Designers can make real-time adjustments, adding or removing material to experiment with different shapes and features. This process allows them to evaluate the prototype under different lighting conditions or from various angles, helping to identify subtle flaws that might not be evident in a digital model. Moreover, clay modeling complements computer design by providing a physical representation of the motorbike, which can be shared with engineers, stakeholders, or even potential customers. It brings the concept closer to reality, allowing for feedback and further refinements before moving on to the final production stages. In this way, clay modeling is an essential step in creating a motorcycle that is not only high-performing, but also visually captivating. After modeling, the next step is part production and manufacturing. A skilled technician begins by building the titanium 4-cylinder, 4-stroke inline engine from scratch. This engine is the heart of the S1000RR and requires extreme precision. The process starts with raw materials like aluminum and steel, shaped into parts using high-tech machines. Each part is carefully inspected and checked against the computer-aided design model to ensure it meets strict tolerances. This means every piece must align exactly as designed, with no room for error. Workers use advanced tools to measure and validate each part before moving forward. These checks are crucial to guarantee that all parts work together seamlessly during assembly. Once the engine block is prepared, smaller but essential components like pistons, crankshafts, and camshafts are carefully installed. To ensure these parts work seamlessly together, high-precision fastening techniques are used. This guarantees that every piece, including advanced features like BMW's signature ShiftCam technology, performs as it should. The ShiftCam system is particularly important because it adjusts the timing and lift of the engine's valves, allowing the engine to deliver top performance at both low and high speeds. Each component must fit together perfectly, as even the tiniest error in assembly could lead to serious engine problems or complete failure. For example, if the pistons or crankshafts are even slightly misaligned, it could cause vibrations, power loss, or damage to other parts of the engine. This meticulous process ensures the engine runs smoothly and reliably. For S1000RR component production, advanced machines called computerized numerical control machines are used. These shape the parts with amazing precision, making sure there's minimal waste during the process. Also, by using the correct machining techniques, the parts are protected from issues like internal stress or cracks, keeping them strong and reliable for their intended use. This careful process ensures that every motorcycle piece is built to last and perform well. Testing is done in special rooms to ensure the conditions are just right for accurate results. Software is used to fine-tune and adjust different variables, helping to understand how they affect each other. This process improves functionality and durability by reducing wear, noise, and vibrations. Crankshaft balancing and tolerance checks are also performed to make sure the counterweights perfectly balance the forces created by the pistons and rods. For advanced tasks, multi-axis robots are used to work on complex aluminum composite bridge chassis areas for precision and consistency. A robotic coordinate measuring machine then checks the dimensions to confirm everything is accurate. To ensure the S1000RR's stability, slope incline tests are performed. These tests help determine how stable the bike remains when positioned at various angles, ensuring it performs well on uneven surfaces or steep inclines. For instance, in real-life riding, this stability is crucial when navigating hilly terrain, taking sharp turns on winding mountain roads, or riding on steep driveways. The ability to maintain balance and control at different angles gives riders the confidence to tackle challenging routes, whether climbing uphill during a spirited weekend ride or maneuvering safely down a steep slope in wet or slippery conditions. This testing ensures the bike remains steady and predictable, even in demanding scenarios, enhancing both safety and rider experience. For welding the bike's frame, highly advanced 7-axis robots are used. These robots can move in 7 different directions, including up, down, left, right, forward, backward, and rotate. This level of precision allows them to perform complex and repetitive welding tasks with incredible accuracy. On average, a 7-axis robot can complete hundreds of welds in just a few minutes, significantly reducing production time compared to manual welding. The precision involved ensures strong and durable joints while preventing issues like unwanted stresses that can weaken the parts over time. Now, in the engine assembly process, essential components like pistons, gaskets, pulleys, and valves are carefully installed to complete the engine. The production is managed by around 150 technicians working in shifts, and together they assemble approximately 500 engines every day, including 2, 4, and 6-cylinder models. This combination of human expertise and robotic precision ensures every engine meets high-performance standards. After production, the components of the S1000RR are sent to the paint shop, where they receive stunning colors and a flawless finish. Each day, over 10,000 parts in 160 different shapes and 25 vibrant colors are coated with high-grade paint to ensure durability and visual appeal. The painting process is done by advanced robots specially designed to apply paint evenly on components of all shapes and sizes. These robots use precision technology for a flawless finish, regardless of the complexity of the surface. One key aspect of their precision is controlling paint density and thickness. The robots adjust the paint spray to apply just the right amount of color, preventing streaks, uneven coating, or wastage. They also ensure consistent color density, meaning every inch of the surface receives the same depth and vibrancy of color. For example, if a part has tight corners or curves, the robots can maneuver their spray nozzles to reach those areas without overspraying. They use sensors and pre-programmed paths to adapt their application for each unique shape, ensuring the final product looks smooth and professional, whether it's a large flat surface or intricate detailing. The vibrant colors and sleek finish make the S1000RR stand out and also protect the bike from wear caused by weather and road debris. The premium paint ensures that the bike maintains its eye-catching appearance for years, enhancing its overall value and the pride of ownership. After the meticulous paint job, the production process moves to the assembly line. In the S1000RR assembly line, careful attention is given to every detail, starting with the application of pinstripes and tapes on the fuel tank and fairing components. This task requires a steady hand to ensure precision and consistency. But why by hand and not automated? The application of pinstripes and tapes on the fuel tank and fairing components is done by hand rather than using robots or automation because it demands a high level of precision and artistic skill that machines cannot easily replicate. Pinstripes are often very thin and need to be applied with consistent spacing, smooth curves, and sharp edges. Even a slight misalignment or unevenness can ruin the visual appeal of the design. Human hands, guided by years of experience, can make tiny adjustments in real time, ensuring that every stripe and tape is perfectly aligned with the curves and contours of the surface. Additionally, some designs may involve intricate patterns or customization based on customer preferences, which require the flexibility and creativity that only a skilled artisan can provide. Robots, while excellent at repetitive tasks, lack the ability to adapt to these fine, unique details with the same level of finesse. Next, the painted fairing panels are meticulously adorned with stickers and the iconic BMW logo, also applied by hand to guarantee a flawless finish. Once these components are complete, they are installed on the bike, bringing together its design elements to enhance its aesthetics and overall appearance. The attention to detail makes the S1000RR a head-turner and highlights its premium quality, reflecting the care and craftsmanship that go into every detail. During the S1000RR's assembly, motorcycles are securely fixed to one of 300 rotating hooks in a flexible conveyor system, ensuring smooth movement through the production process. Once the engine assembly is complete, the next critical step is dyno testing, a process used to evaluate and fine-tune the engine's performance. For a high-performance motorcycle like the S1000RR, every detail matters, so rigorous testing is essential to ensure it meets the highest standards before being shipped to a customer or displayed in a showroom. During dyno testing, the engine is put through its paces to measure key performance metrics such as horsepower and torque curves. These figures are vital because they reveal the engine's power output and efficiency at different speeds and loads. For instance, the torque curve indicates how the bike will respond when accelerating, while the horsepower measurement shows its capability at higher speeds. This testing doesn't stop at just raw numbers. It also ensures the engine operates smoothly and reliably. Engineers use the data to fine-tune components, adjusting fuel delivery, air intake, and other settings to maximize performance. Additionally, this process checks for potential issues such as overheating or vibrations that could affect the engine's durability. Before the bike is cleared for shipping, it undergoes another round of tests to confirm that every aspect of its performance aligns with BMW's stringent standards. This exhaustive approach leaves nothing to chance, ensuring the S1000RR delivers not only peak performance, but also the reliability and thrill that riders expect from a world-class machine. This commitment to quality testing gives riders the confidence to push their bikes to the limit, knowing they will perform flawlessly on the road or track. After production, each S1000RR motorcycle is transferred to the inventory, where it is stored alongside other iconic BMW models, such as the Adventure, Roadster, and Tourer series. This step ensures the bikes are organized and ready for the final stages of preparation before they reach their destination. The next phase involves carefully packaging the motorcycles to protect them during logistics and transportation. Highly precise wrapping robots are used to package the bikes securely. These robots apply protective wraps to shield the motorcycles from dust, scratches, and other potential damage during transit. At the same time, identification stickers are applied containing essential tracking information to monitor the bike's journey from the factory to its destination. Once wrapped, the motorcycles are placed in specially designed hard cardboard boxes. These boxes are engineered to withstand the rigors of transportation, providing additional protection against impacts and environmental factors. The secure packaging ensures that each S1000RR arrives in perfect condition, whether it's heading to a dealership showroom or directly to the customer. This meticulous process highlights BMW's commitment to quality and attention to detail, ensuring that every motorcycle is delivered in pristine condition, ready to provide the thrilling experience its riders expect. From there, they are shipped to customers in 130 different countries using trucks, trains, and cargo ships. This carefully planned packaging and delivery process ensures that every S1000RR arrives in perfect condition, ready to hit the road or track. It guarantees that the bike is delivered safely, no matter how far it travels.